Hello guys, welcome back to the Maths Club. This is Paul Ayok, your mathematics instructor. In my previous videos, I handled equations relating to radical functions, that is radical equations. Those videos are posted on my YouTube, Instagram, Facebook and TikTok pages. So you can comment, share and like. You can also post alternative solutions to the solutions that I have been posting so far. You might not be interested in mathematics, but you can also share to those who are interested in mathematics. The concepts I explain here might help others who are interested in mathematics. Today, I want to handle a different concept, and it has to do with the binomial expansion. The binomial is a two-term expression. And the question on my board is a past IB Mathematics AA, that is analysis and approaches, standard level question on binomial expansion. So guys, let's walk through this question and see what method could be applied in handling the question. So on my board, it is given that the binomial expansion of 1 plus kx to the n is given by 1 plus 9 on 2x plus 15 k squared x squared plus that plus k n x n, which is the last term. Find the value of k and the value of n. N belongs to the set of positive integers. So what is the method? The method is simple. They say this expansion is the same as this. This binomial expansion, this one is the same as this. So it means we have to expand this binomial and equate it to this expansion. Then the constant term on the right hand side should be equal to the constant term on the left hand side. The coefficient of x on the right hand side should be equal to the coefficient of x on the left hand side. And the coefficient of x squared on the right hand side should be equal to the coefficient of x squared on the left hand side. So for us to expand that binomial, I'll begin with the general formula for expanding the binomial a plus b to the n, which is the sum from r equal to 0 right up to n of n combination r, a to the n minus r, b to the r, where r can take values 0, 1, 2. Why will I stop at r equal to 2? Because the expansion ends at x squared. So if the expansion continued at x cubed, I would have ended at r equal to 3. So take note, I'm ending at r equal to 2 because the expansion ends at x squared. So therefore, the expansion 1 plus kx to the n could be obtained as, in the place of a, I will replace 1. In place of b, I will replace it with kx in this formula. The n is still equal to n. So when r is 0, this formula becomes n combination 0, a, which is 1, to the n minus 0, b, which is kx, raised to the power 0, because I'm substituting r as 1 inside this formula. Plus, why am I bringing a plus? Because I'm dealing with a summation sign. Summation means we are adding. So plus r now equal to 1. When r is 1, it becomes n combination 1, a, which is 1, to the n minus 1, because I'm substituting r as 1, b, which is kx, all to the power 1, plus, when r now is 2, it becomes n combination 2 times 1 to the n minus 2 kx to the power 2. So this implies my expansion 1 plus kx to the n will actually be equal to n combination 1 raised to the n will be equal to n combination 0 n combination 0. 1 raised to the n minus 0 is n. 1 raised to the n is still 1. Kx raised to the power 0 is actually 1. So this entire product here is actually 1. So plus n combination 1, 1 raised to the n minus 1 is actually 1. Kx raised to the power 1 is still kx. Plus, look at this term, 1 to the n minus 2 is still 1 times kx raised to the power 2. So if I'm squaring this bracket, I will square the k and I will square the x. So it becomes n combination 2 k squared x squared. So this implies my 1 plus kx all to the n is the same as n combination 0 is actually 1. Any value combination 0 is 1. N combination 1 is n. Multiply it by kx will be nkx plus n combination 2 is n into n minus 1 all on 2 k squared x squared. So we have been told that this expansion is the same as this. You see that 1 is equal to 1. So this coefficient here, this coefficient of x, which is nk, should be equal to the coefficient of x here, which is 9 on 2. Because those expansions are the same. The expansions are the same. So nk should be equal to 9 on 2, which I can call this as equation 1. Then the coefficient of x squared on the right hand side here, which is this coefficient, should be equal to the coefficient of x squared in the original expansion, which is 15k squared. So 15k squared should be equal to n into n minus 1 on 2k squared x squared. K squared. So because we are equating coefficient. So this k squared cancel with this k squared. You see that 15 equals n into n minus 1. All this on 2. So I will multiply here by 2. I multiply here by 2 so that this 2 is eliminated from the denominator. So I multiply here by 2. I'll have 30 equals n into n minus 1. So what I've actually done is to multiply here by 2, multiply here by 2 so that the 2 and this 2 in the denominator, they cancel out. So therefore 30 is equal to n squared minus n. So I will subtract 30 here and subtract 30 here because I'm already seeing a quadratic equation that is forming. So 30, I'll subtract 30 on both sides, n squared minus n minus 30. So you see that these guys cancel. So n squared minus n minus 30 equal to 0. And when you look at it very well, the factors, or to factorize this quadratic, I will have n minus 6 into n plus 5 equal to 0. That's the factorization of n squared minus n minus 30 equal to 0. So from here, we see that n equal to 6 and n equal to negative 5. But we are told that n is a positive integer. So this negative 5 cannot be a solution for n. So the actual solution for n is 6. And when n equal to 6, substitute n equal to 6 in equation 1. In equation 1, this equation, for us to obtain a value for k. So we have 6k equal to 9 on 2. So I'll divide here by 6. I divide here by 6. So K should be 9 all over 2 divided by 6. K should be 9 on 12. K should actually be 3 cancel here, 3 cancel here, 4. So K is 3 all over 4. 3 all over 4. So K is actually 3 on 4 and N is actually 6. So I will be posting my bonus challenge in the comment section. Like, comment, you can share your alternative solution. I know that there might be other methods of handling this question. So post it in the comment section. Follow me, like on Facebook, on Twitter, on Instagram, on YouTube, and on TikTok. Watch out for my next video. Thank you.